Hello students. In this video I'm going to work through the problems that were on our review and hopefully it will help you prepare for the quiz. Let's start with the border problem. The border problem questions wanted us to revisit the days that we spent looking at the border around a 10 by 10 square. And through that process we eventually worked so that we could create an expression to represent any size side square. So we came up with a variable n. So one example, and there's many examples, the answers can vary on this. So one method that was shown in each class was to go all the way across the top and all the way across the bottom, and what would be left on the side would be 2 less than the actual length of the square because we use a corner here and we use a corner here, so those 2 corners will subtract 2 from what the original side was, and it's the same on the other side. Since we are doing perimeter, we're just going to add these up. And I just chose to add in a clockwise direction. So I wrote n plus n minus 2 plus n minus 2. And I ended up with this long algebraic expression. So if I were to simplify this expression, I'm going to combine all my like terms. I'm going to count my n's. I have 1n plus 1n plus 1n plus 1n. And all of those n's add up to 4 n's in total. Now I look here and I have a subtract 2 and I have another subtract 2. Well, if I subtract 2 and then I subtract 2 again, I will have subtracted a total of 4. So my simplified expression ends up being 4n minus 4. All right, on this next one, here's another example that came up in our class. The student came up and showed, well, I'm going to start at a corner and go all the way down, but then stop here and not use this corner. So in the example in class, I believe they used the number 9 instead of 10 because they stopped 1 short of the next corner. And then they continued their pattern. You start at a corner and go all the way until you get near the corner, but stop. And then go start at a corner, go all the way up until you get next to the corner, stop. So each piece contains one corner, but not the other. So if we look at this, each piece, each side here is 1 short of the entire n. So algebraically, that would be n minus 1 because it's almost the whole side, but it's minus that one piece in the corner. So we ended up having 4 of those. So let's write our algebraic expression. Here's our algebraic expression. And if I were to simplify this, I'm going to combine all my like terms again. So I'm going to count my n's, 1, 2, 3, 4 n's, and I'll put those together. And now I will count my constants, negative 1 or minus 1, negative 1 plus negative 1 plus negative 1 plus negative 1. That is a total of negative 4, which I can write as minus 4. So if you notice, and if you remember from the activity we did, all of our answers ended up being, when simplified, 4n minus 4. Okay, let's move on to the section involving terms of an expression. So we start with a question to make us look a little closer. Are all of these terms, there are 4 of them, are they all positive? And depending on where we're at in our understanding, some of us might look at first and think they are. But if we look closely, we know that a minus sign, when we add the opposite, a minus sign could turn this into a negative 38. So if I do keep, change, or add the opposite of 38, negative 38, and if I do keep, change, and add the opposite of 47, negative 47, I see that these 2 terms are actually negative. So I'm going to say that no, all of these terms are not positive. Now I need to identify the terms, and terms are separated by a plus or a minus sign, and I see I have 4 of them, so all I need to do is list these 4 terms. So that's exactly what I did. I wrote 10x, that's my first term, then I wrote 36, then I wrote negative 38x, make sure that negative's on there, and then I wrote negative 47. Now I'm going to identify my like terms. Like terms have the exact variable or variables with the exact exponents. Or in class, I always say they have the same last name. So 10x has the last name of x, and negative 38x has the last name of x. So that's one set of like terms. My other set of like terms in this expression are my constants. A constant, just a number, no variable. So I have 36 and 47. They are like terms because they do not have a variable. They're just called a constant. In order to simplify an expression, I am going to combine my like terms and then write my new expression. All right, so I showed my work here. I put my like terms of the x's together, and I had negative 38x plus 10x, and that leaves me with the negative 28x. That's one of my terms. I put my constants together, and that's 36 plus negative 47, and that leaves me with negative 11. So either of these two will be acceptable ways to write your answer. You can say negative 28x plus negative 11. You could also say negative 28x minus 11. That will get you, that's the same expression. All right, another example like the one we did. Well, hopefully we learned from the other expression that if we see a minus sign, we better be on high alert and look closely, because that's probably going to tell us that this is really a negative 3. And sure enough, it is a negative 3. If I perform add the opposite or keep, change, sure enough, this becomes a plus negative 3, this becomes a plus negative 2b, and this becomes a plus invisible negative 1x. All right, so I'm going to say no again. These are not all positive. And now I'm going to go through and identify my terms. Remember, terms are separated by plus or minus signs. So I have 1, 2, 3, 4. I have 5 terms in this polynomial. All right, here are my terms. I start with 5x, then I have negative 3, then I have 6, then I have negative 2b, and then I have negative 1x. So when I identify my like terms, I'm going to go to my highlighting method. So I highlighted the 5x and the negative 1x. And next I went for my constants, my negative 3 and my 6. Now, negative 2b, there are no other b terms in the expression, so that guy's just going to be all by himself. So now when I simplify my expression, all that is doing is combining like terms. So I'm going to take my 5x and my negative 1x, and 5x minus 1x is 4x. Next, I'm just going to bring down my negative 2b and put that in the middle. You really could put it at the end if you want, because of the commutative property. You can move it around. And then I have a negative 3 and a 6, and if I combine those or add them, I get a positive 3. So my final expression is 4x minus 2b plus 3. Now let's work through the problems on the back of the review. Here we're going to do a sum. Before we start, though, we're going to need to distribute this 7 by multiplying it into the parentheses. So my students know you get a car and you get a car. All right, when I perform that multiplication, I get 7 multiplied to 8q, which is 56q. Then I get 7 times 1, which is 7. Now I'm going to set up a the vertical method to add my two expressions. All right, so when we do the vertical method, make sure that we line up our like terms. So I have my q's on top of my q's and my constants on top of my constants. Now I'm just going to add, going down, 56q plus negative 3q. that should give me a 53Q. And then I have 7 plus 3, which is my birthday, July 3rd. And 7 plus 3 is 10. Now, kids in my class know that I'm going to say stop. We're going to stop right here. That's our expression. We're not going to go any further. All right, for this next problem where we're subtracting two polynomials, what I want to do, I'm going to show you the vertical method, and the way I teach it is we can set it up like a subtraction problem, but I always tell my students, let's put a subtraction here and let's put a subtraction sign here, because we are subtracting this column and we are subtracting this column. We're subtracting both of these. So let's start here. 12x minus 7x. I think we can do that without doing keep, change, change. 12x minus 7x is 5x. Okay. Now, here we might want to do add the opposite, because I have negative 5 minusing 11 negatives. So I'm minusing 11 weights from my air balloon or from my submarine. And so if I minus weights and I do add the opposite, I'm really going up 11. So negative 5 plus positive 11 is what's really going on. And that gives me a positive 6. So this expression, after we add the two together, or I'm sorry, subtract, we get 5x plus 6. And then we're going to stop. All right, if you were in class the day that I taught substitution and evaluating for a variable, a value for a variable, you know that on my board I drew a box where the variable is in the expression. So we have 3d, which means 3 multiplied to d minus 8. So what I am going to do is I'm going to grab this negative 6 and I'm going to substitute it in the spot where the variable was. So I'm going to go like this and write negative 6 right here. I highly encourage you to do this on assignments and quizzes and tests. If you do this, you will remember to have that value, even if it has a negative, right there. So now I'll do order of operations. I know that I need to multiply before I subtract, so 3 multiplied to negative 6 is negative 18. And if I were to minus 8 from that, I could do that in my head, or I could do a little add the opposite, keep, change, change. So 18 negatives plus 8 negatives is 26 negatives. So if I evaluate this expression for the value d equals negative 6, my answer is negative 26. All right, last question. So we have this expression, and I rewrote it like I want all my students to do, and put a box where the variable is. Okay, leave an empty space there. A box is really nice. And then I'm going to evaluate or substitute in the value of negative 5 for where the variable x. And if you notice, there was a mistake. A lot of my students caught that. This should really be b equals negative 5. This should be a b because there is no x in the equation. So I'm going to take my negative 5, I'm going to write it in this box, and I'm going to write it in this box. Now, we can do parentheses first, or follow the order of operations. In the order of operations, we're going to multiply before we add, so I'm going to evaluate 3 multiplied to negative 5, and that equals negative 15. And then I'm going to add that to 8 because I'm still in my parentheses. And 8 plus negative 15 gives me a negative 7. So this parentheses evaluated out to negative 7. Well, I'm going to jump over here and look at this. I have a negative 5. So one way to look at this is the opposite of b. Negative means the opposite of. So the opposite of b, or the opposite of negative 5, is 5. And if that did not make sense to you, that's fine. Let me show you another way to look at it. There's a little tiny skinny invisible -1 right there, and that's multiplying the b. So -1 multiplied to -5, two negatives make a positive. So that's how I ended up with a +5. Well, now I can finish my problem. 5 multiplied to -7 is -35. And that is the answer I get if I plug in a value for b of -5. All right, I hope this helped.